Hi, everyone. Today, I wanted to talk to you about the information age, big data, and data analytics. To begin, I wanted to ask the question, when did the information age start? Think about it for a second. Was it the 1980s, 1970s, 50s? When did the information age start? Well, you can pause and think about it, or we can move on. We can say that it probably started about 5,000 years ago. That's because the information age starts with the historic age. We have an interesting set of quotes and images here. No records, no history. So history is actually synonymous with the information age, since prehistory is that age in human development that precedes the availability of recording systems. It follows that one may reasonably argue that humanity has been living in various kinds of information societies, at least since the Bronze Age, the era that marks the invention of writing in Mesopotamia and other regions of the world, 4th millennium before Christ. This comes from Luciano Floridi, Information, a very short introduction. Here we have some of the stones, supposedly with the earliest known writing, Kish Sumer writing. So in a way, we have been living with the availability of recorded information for a long time. Now, though things, of course, are a little bit different, and maybe we are in a hyper-information age. All sorts of our activities are recorded, they're processed, they're stored in computer servers, in mobile phones, in database servers, the emails you send, the online registration events, you're walking around the street is being recorded, your credit card transactions, the social media posts, the library, books you rent, the books you purchase online, and so on and so on. So we're living in this kind of era of big data, as they call it. To provide a little bit of context to this growth of data, I like to point out the association between the rise of the service industry. So the economies of the world changed a lot, in particular in so-called developed countries, where there was a surge of the service industry. So information activities, communication activities, legal activities, financial activities, education, and so on. Whereas the manufacturing sector has been either flat or going down. So here's 1960, 1959. This is the service industry growth, and this is in the US. And you can see the huge rise of the service industry, the tertiary sector. Obviously, the same pattern in other countries as well, even in China. So in China, share of agriculture, percent of share of agriculture, people who work in agriculture has been going down over the years. And industry and services has been growing. So in China, of course, they are the manufacturing country of the world almost. And their manufacturing has been growing, and their service industry too, with agricultural decline. Of course, there are many reasons for that. Here's India, also large growth in the service industry. The manufacturing or industry per se is going down. I'm sorry, actually relatively flat. There's the blue one here. This is industry. So agriculture definitely going down. And this is, what is this? This is percent of people employed, percentage of people employed in this area. So it's not that they're producing less food, it's that the mechanisms to do so are more efficient and there needs less people to do that. Service industry going up, sort of manufacturing relatively steady. So a little bit of difference across countries for sure. And now we are in the so-called Zettabyte era. In 2003, a calculation by Berkeley's School of Information Management and Systems estimated that humanity had accumulated about 12 exabytes of data, recorded information, in the course of its entire history until the commodification of computers. Between 2006 and 2010, the global quantity of digital data will have, that was that time when they wrote it, have increased more than sixfold from 161 exabytes to 988 exabytes. I didn't really check now. I don't think it matters. This is not kind of number that is possible for the human mind to comprehend fully, but if you want a kind of diagram, you can see where exabyte is. So these are 10, these go up by 1,000, so megabyte, 1,000 kilobytes, gigabyte, 1,000 megabytes, terabyte, 1,000 gigabytes, and so on. So exabyte is over here. So we are living in an zettabyte era, or the era of big data. And we can see that from the frequency of the term big data. This is average monthly frequency of the term big data being used since 2012 and 2013. So this became a topic as well, but in a way, kind of a trend, perhaps a marketing trend, perhaps a hype, which can be attributed to the promotional initiatives by IBM and other leading technology companies who invested in building the niche analytics market. So we kind of have to be careful here too, to always discern, truth from marketing often, and hype. Humans are generally kind of very gullible, but here we can explore some of these ideas more completely. In a sense, obviously, we're living in an era of the zettabyte era, the era of a lot of data, but also these notions of big data, or the need for technologies with big data, has a strong kind of marketing and promotional component as well. Big data is a term that describes large volumes of high velocity, complex, and variable data that require advanced techniques and technologies to enable the capture, storage, distribution, management, and analysis of information. This is coming here from this writing, Gandomi and Hayder, which I will also share with you in the course, and you can take a deeper look into this paper. And big data is usually characterized by the 3 V's. So that's volume. There's a lot of volume. The amount of data generated is huge. There's online transactions. There are offline transactions that get recorded in systems that are connected to the internet, or not, but somebody has a handle on them and can process them. Kilobytes or terabytes, gigabytes, and so on, saved in records, tables, files, kind of, or structured in a way. Velocity, the speed is very fast. The technologies of data communication increase. So from 4G to 5G and so on, the speed and the bandwidth that people have in their homes and their offices has been increasing. Data is generated in real time, once again, online and offline, stream, batches, or bits. And variety as well. So it is both structured and unstructured data. There are these data in the tables and the files that are well organized and kind of chopped up for ease of processing, but also there's unstructured data, videos, images, other data that can be processed, but not readily structured for conventional manipulation. Online images and videos, human-generated text, machine-generated readings, and so on are also out there. And after the famous 3 V's of big data, then people kind of came up with additional V's to explain big data. So veracity, which refers to the unreliability inherent in some sources of data. So for example, customer sentiments and social media are uncertain in nature, since they entail human judgment, yet they contain valuable information. So There's a kind of veracity in the data. It's a lot, it's big, but it's also a little bit complicated. There's variability and complexity. So this refers to the variation in the data flow rates. So the volume and the velocity are not particularly consistent. So often big data velocity is not consistent and has periodic peaks and troughs. Complexity refers to the fact that big data are generated through a myriad of sources. This imposes a critical challenge: the need to connect, match, cleanse, and transform data received from different sources. Value: big data are often characterized by relatively low value density. So any one piece of information may not be that valuable, but in aggregate, it's valuable. The data received in the original form usually has a low value relative to its volume. However, high value can be obtained by analyzing large volumes of such data. I don't know if these terms are that much different than the first three, but people are adding out there. This also comes from the same paper I've been referencing, so you can take a look at that at your own time. And I have here, I added this image here just to kind of contextualize and exemplify big data as well. I was looking to the open data systems of New York City to just to browse around, understand the kind of data sets that they have and they provide openly for anybody to process. And I just stumbled upon one data set of parking violations issued to see if we can maybe use this as an exercise or to work with. And you can see just this one data set, one of the thousands of data sets that they have. It has 2.82 million rows of data and 43 columns or fields or the attributes of each parking violation. So this is a huge amount of data. And the fact is that everything we do is being recorded, and there are lots of humans, there are a lot of actions, a lot of processes. So big data, it is in a way everywhere in the most sort of mundane of things. And I think this sets us up well for the continued conversation we'll have about big data and data analytics. So we'll continue this next time.